Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about navigation with Indian constellation or NavIC update of 2025, mid 2025. So let's dive deep into it. So you have to understand certain history of things. Basically, India has two naughty neighbors, let's just call it that. One we call Pakistan, another we call China. Now, problem with that is that border conflicts and war is a frequent event, meaning it's not that it's going to happen. It's like, when was the next or when was the last? It's always there. It's never ending. It's like, it is what it is. You just go with it. Now, India had a serious war, something that escalated from border conflict to like serious boom boom in Kargil 1999. At that point in time, India did had a partnership with the USA, and we did had GPS and all that, but GPS was denied. That's why like we could not send fighter jets inside Pakistan to shift delete them. But that was a very important, very good friend bitch slap, and we learned from this bitch slap, meaning thou shall not buy weapons grade important thing from someone else. So in May 2006, it took some time to like figure out how much money and how much technology we need. In 2006, India created NavIC, as in project was created, greenlit, and 1,420 crore. Now that number may sound a bit small nowadays, but that's because of inflation. In 2006, that number was magnificently huge. So a lot of money, and government was like, nah, this is priority. Like, we learned our lesson from Kargil. We learned from Jeb Bezos, I'm saying George Bush, that this is not gonna. Now our approach was a bit different, because you have to understand there are a lot of countries that have a navigation system. So you have GPS, Americas, you have GLONASS, which is Russian, then you have Galileo, which is European, and then you have Bindu, that is Chinese. So all these four, they are global, meaning they should work anywhere on the planet. But India was not going all in for that, because we most of the time don't need that. So idea was, we're going to make a regional system, basically something similar to what Japan has, but Japan is even smaller scale. So we want to make a bigger puppy of that. So idea is, whole of India, we never have to worry about it. And up from our basically border to 1500 kilometer, we do not have to worry about it. It's like, we got this. Like basically we can make sure of whole of Pakistan without any issue, half of China without any issue. Like especially any border area, we good, we got this. Be it in sea, be it in Himalayas, like we good, we got this, we done. And to achieve that, rather than having Leo satellite constellation or MEO satellite constellation, we have Geo satellite constellation, meaning we have four of these puppy that is going in 8 pathway, that is going up and down, and then we have 3 that are in geostationary locked position. They are in geostationary, and another are in geosynchronous. The 8 number one is geosynchronous. So 7 of these puppy gives you complete coverage over the India, with more than enough buffer to take care of any naughty puppy, and does not require too many satellites. Like minimum for a GPS kind of system is like 24, and then you need like 30 to have some buffer and all that. So this was a good starting point. And idea was, ideal scenario, by now if things would have went precisely, we would have upgraded this to global. And yes, it can be done. We'll just keep adding more satellites. So that was the whole point of it, meaning make sure that this bitch slap of 1999 cannot be repeated. So next time Pakistan like tries to play naughty, we are like, nah bro, we too old for that. So that's the history of NavIC. Now the idea started old, like basically things did not go according to plan. Now same way in NASA, you have Inspector General Office of NASA. You have similar thing in almost all country. India also has this, which we call Controller Auditor General of India, CDA, so to say. So the idea was that we're gonna give money. Money was given, and by January 2012, basically when the world's supposed to end, we're supposed to have whole India covered with extra 1500 kilometers. And after that, we're gonna figure out how to go to the next phase, global phase. That did not happen. So here's the deal. The auditor's office, they were raising red flags about this. It's like, bro, what the hell is going on? And in 2018, they did what we call compliance audit. Basically, that was a lot of money. It's like, what the hell happened to the money? And where did it went? Like, why did it happen? Because government has so much bureaucracy. You need someone that has governmental authority to see through it. You can't do it via what we call somebody has to have authority to do that. We generally build something like this to take care of that. So fundamentally, bad things happen. Like, it's bad. Let that be very clear. It's Not good, it's bad. How bad? ISRO bought wrong modems for satellites. How the heck that happened is beyond me, and they burnt 3 crore rupee. Now, again, it's not that the end of the day, but it's like, holy damn, that's like, how the heck you mess it up? It's almost like, oh, I bought a Wi-Fi router for 5 gigahertz. It's like, sir, your transmitter and receivers is 2.5 gigahertz. Oh, that happened. Not even joking. And again, ISRO was running on old computer systems and all that. So a significant chunk of money was put into just to make sure that ISRO can upgrade the whole logistic. Basically, SCADA system, how you have, it also requires a hardware. Same way, software has to be there that is good enough, updated enough that things can be handled, complex projects can be handled. And NavIC at that point in time was the most complex project. So they are like, okay, we have to upgrade those computer systems. So it's basically a new software system, basically to remove ISRO's old administrative software with a new one. That lot of money was allocated, 10 crore, which is not a small chunk of money. It's a like bonkers amount of money. And ISRO just went lol. Not even joking, that happened. It's like lol. Like, what happened to it? Lol. Why you not doing? Lol. It's like just lol. That happened. So that I'm like, literally they had no reason for it. It's like, oh yeah, we do not had people for it. It's like, you got the money so you can hire people for that. But it's like, it's just lolled it, like lol. And here's the deal. Now, again, because India had a good friend known as America that bitch slapped us as very important time, we learned that there are certain things that are important. For example, let's just say you made satellite, because at that point in time, and even today, we know that India has ISRO. If ISRO wants to put some satellite into space, it may be delayed, it may take a bit longer amount of time, it may be cost overrun, but it will be done. Like, we got this, it will be done, sorted, go home. But what about receivers? Now, again, same way we had GPS being cut from US side when we went to Pakistan. What if we went to go to China, and China is the one that is providing the receiver? So they're like, instead of cutting the satellite, they cut the freaking receivers. So they're like, in 2006, cabinet ministers, which are like politicians, bureaucrats and all that, somehow they had brain, and they were like, okay, 200 crore, which is a significant money in 2006, that's like damn amount of money, put there because they classified this as a critical tech, which again, holy damn, they have brain. Critical technology. And the idea was, you're gonna figure out, basically start the foundation so domestically manufactured chips can be done, that can basically, receiver should be like made in India, done, nobody else can control it. Never happened. I'm not even joking, they did not start the project till March 2017. They were just lolling, like they did not even officially start. It's not like, oh, delaying. No, they did not even start. And it was classified as critical tech in 2006. They're like, lol. I'm like, damn. So basically, we have no domestic manufacturing, which should have been done. That was the whole point of classifying it as what you call critical technology in 2006. So that's there. And most contracts, because again, ISRO will give out contracts to other companies who are building some solid boosters for rockets, or the whole rocket, this part, that part, all that jazz. Most of them were either delayed or incomplete, and some were delayed by 9 years. So, lol. So, and the whole rollout got delayed by 6+ years. So that was not comfortable. And here's the deal. Whenever you're dealing with something like this, you have to understand that ISRO has branches all over India. So some branches in Bangalore, some branches, heck, in Bangalore you have multiple branches, and some are in Delhi, some are in Mumbai. Like, you have, it's spread around the country. That's the whole point of it. But here's the deal. You need to have a committee, because if you're doing a project that is not limited to one site, it will have a lot of overrun. You have to have a way of communicating. Somebody has to be responsible for it. So again, project was designed, project had a system where it's like, okay, ISRO is going to select people to take care of this. Yeah, committee never existed. They were just like doing their own thing. They're just like, yeah, we gonna like, lol. So that was there. And lack of high level push was like flat out not there. Like, there was nobody top enough. Even though this was a national security project, then they were not like, okay, we have to have this project cannot be there. Other things, cool, GG. But this is absolute. This is not like, oh, lol. No, this has to be done. And if there is an issue, you brute force it. But that was never done. And basically, they ran it bad. Basically, the whole project, even though this was a national security project, it was ran like, who cares? This is from their report. I dare you to read the whole report. So, yeah, it was bad. Let that be very clear. 2018 compliance audit from CGA. Good luck. It was bad. Let that be very clear. It was hilariously bad. Like, it is so hilarious because, again, otherwise I will cry, but like, it's hilarious. Now, on top of that, we stumbled through, but we finally did get a launch. And then this problem happened. Atomic clock started to fail. Now, core of all satellite navigation, it does not matter whether it's a regional system or a global system, all of them rely on atomic clocks. They have to be. And atomic clocks so precise. Let that be clear. There are different grades of atomic clocks. So you had like ancient grade that we used to use in mobile phone towers. Those are sloppy ones. That's not good enough. We need something that is precise enough that because you are traveling at orbital velocity 24 into 7, your speed will cause time dilation, meaning you will drift in nanoseconds per day, and the clock has to be precise enough that should be measurable. It's like, yo, I drifted, so you do a compensation. That's why atomic clock is very important for global navigation. If we could not make the clock, we could not make the navigation. You will think with radio, no, that's just like no. So fundamentally, we needed atomic clocks for that, and we utilized rubidium atomic frequency standard. Nothing too complicated, but we bought it from Spectratrine, and they had some issue, and apparently they had systematic issues. So it's not like, okay, they had like, we got the bad batch. No, like somebody who was supplying to them messed up the capacitors, and capacitors were overheating and frying, and they were frying the whole system down the chain. So fundamentally, ISRO had a serious issue, and so does ESA. ESA's Galileo system also had this sort of watches as a backup, and other some auxiliary systems, they were also getting kaput. So it was bad. Now here's the deal. We need seven satellites to do the whole India. But every satellite, because again, clock is such a high priority thing, every basic satellite has 3 clocks, and basically 1 primary and 2 backups. I, R, and SS, basically Mark 1 satellites, one of them, basically A1, unfortunately had all 3 fail. And again, let that be very clear. So what does that mean? That simply means that satellite is kaput, done, the end, shift deleted. It cannot serve a navigation function, meaning now the navigation is degraded state. So that happened. And here's the deal. It's not limited to one satellite. So you could say, like, what if it has a power rail failure that overstressed the capacitor and kaput it? You know, out of 24 clocks that are in space, 9 of them went kaput. That is too high of a failure rate for a space system, for a national defense level equipment. So that was by May 2018. So it was not good. Now again, it was another bitch slap from European friends. So we learned, and we started indigenous atomic clock project just to make sure that we do not get bitch slap again. And we started to create a new batch of satellites, this puppy, which we call NVS1, basically navigation sats. Navigation sats 1, they have upgrades and indigenous atomic clock, meaning we never have to worry about somebody else not maintaining their supply chain and kaputting the whole national security project. So atomic clock was also a very frustrating thing, because again, you might think like, okay, we were smart enough to put 3, but here's 9 of them are already kaput out of 24. That's like, yeah, they're gonna be kaput. So atomic clock wise, like, yeah, we learned the lesson the hard way, so to say, why you shall not buy from someone else. Actually, ironic part is we bought it from European people because they were using it in their GLONASS. So everybody was like, no, that's a safer route. Turns out that fried us. Like, we Indians are really not learning that. Like, there are certain things you do not buy from abroad. You just don't. Like, you just no. Now, on top of that, those the atomic clock kaput. What about satellites? Satellites, the first satellite was launched in orbit in July 2013, which was like, we were expecting by that time, it's like, bro, we are working towards global constellation. We are like, yeah, first satellite. And that satellite became the unfortunate one where all 3 went kaput. So by January 2017, the satellite went kaput. Now again, satellite was working. The whole power electronics, everything was okay. Just that clock was not. So basically it was a message relay satellite. It was no longer navigational. So that was there. And we need 7 for functional systems. So Mark II systems were like upgraded. Now the biggest upgrade was that, because again, this is very early 2006 kind of design and all that. So they did not have like foundation of mobile GPS as we have right now, because you have to understand that the whole foundation was done in 1999. Now that time GPS was not open for public. It took a very bad plane crash, you can write down below which one, where they're like, okay, GPS will be unlocked for everything. So navigation of aviation industry and maritime industry instantaneously bought it. And as other countries started to make their own system, like Galileo, Baidu, and what was the GLONASS, all of them, the mobile companies started to make a really a serious improvement. And by this time, like basically when we are making the Mark II one, they're like, yeah, we do not have the right frequency for that. And again, same thing has happened with GPS also. GPS, like, in 70s, they had a different frequency versus later words. So Mark II satellites, they have different frequency, L1 band. So L1 band is 1.5 megahertz band. Now, if you're like, that sounds familiar, yeah, that's the same frequency right now used by all major navigation system, all the four, Galileo, Baidu, GPS, and GLONASS. All of them utilize the same frequency. So idea was that if we can have transmitter of this system, all the silicon manufacturer who are basically Qualcomm and all that jazz, all they have to do is firmware tweaks, algorithm tweaks, because again, it is a bit different algorithm. Again, lot of algorithm difference happens between Galileo and GPS, but again, it's fundamentally different mathematics going from a global system to a static system, regional system. So they would require a firmware update, but it would be doable. So that's the whole point of upgrade, or like Mark II batch 2 upgrade, so to say. And unfortunately, once we launched this, Mark 1 worked awesome. Basically, Mark 1 of version 2, then we were like, okay, NVS 2 number 2 was launched, and it had launch anomaly. The satellite's system, thruster system, the satellite has its own thruster system, so it can go from low Earth orbit to high Earth orbit, geostationary orbit. Yeah, that kaputted itself. It's not in the right position, so it's stuck. Yeah, that's bad. So what does that mean? That simply means at this point in time, even though our army, our navy, and our air force, they're good, they got this, it will still take some time before we have a fully ready regional NavIC system with Mark II technology, with all our indigenous clock and much higher reliability. And because again, the satellites also went through a design redo, so the lifespan has been upgraded from 10 years to 12 years. So that's and again, you do want a bit more leeway. Always you want a bit more leeway. So it's gonna take a while. So I would expect by 2030 we should have this thing sorted. So what can we expect in the future? Now here's the deal. It's normal to have problems in project, and this is the one of the primary weakness of India. That's why we are not the superpower, simply because our railway, awesome, we are moving people like there is no tomorrow. Like if you want to understand the scale of us, yeah, we have whole Australia on wheels 24/7. Yeah. So trust me, like when we say like we know how to move people, we know how to move people. And you're like, okay, accidents are no. Compared to the population of we are moving, it's like, yo, number is tiny. So fundamentally, my apologies. Whenever we start a project, it fails. It has some issues, right? Mark 1 is always garbage. We stop the project. Same happened with our own fighter jet. We started it just after independence, and we shut down the project. Everything we have the same issues. Like we started, we shut it down. But this is normal, and this is the hard thing we are not learning. But thankfully, because again, America bit slapped us already in Kargil, we learned the idea that we cannot abandon certain things. I'm very happy that NavIC has reached that point where it's like no matter what happens, NavIC will be made complete, no matter how much money it takes. It's a national security project. It will be done. But all that being said, I'm very happy with her. But like, holy damn, the mismanagement of the system was like, damn, what were you smoking? That was bad. So basically, India needs to persist. That's the whole point of it. And again, independent navigation, that's a GG system. We have to do this. And I have to specify this also, and it will help you guys who are trying to understand what the hell is going on with Russian technology and American technology. USA is powerful not because they make the best product, because they keep polishing it. For example, if you look at Russian systems, Russian helicopters, Russian planes, Russian fighter jets, everything is awesome, right? You try to look into it, everybody is orgasming every time we are talking about it. It's like, again, same happened with Japanese systems. It's like, yeah, this is awesome and all that. I'm talking World War II. Everything is GG. It's like, and again, compare that to American system. Oh, we had this problem. Oh, Patriot system. Oh, missile did not had a very good identify friend and foe. It boomed its own self, as in like own member, is all that jazz. So similar thing happened with Buff B-52, and basically they made it. The design was made, and they effed up, and tails were flying off. Not even joking, tails were literally kaputting itself, and the whole thing has to be rebuilt, reinforced, and rebuilt, and they did it. That's the whole point of America. It's not that they start with something and it's like GG, like how how Russia claims everything is like GG. They make it, we have this problem, there is a hearing and this and all that, and then somehow their brain turns on and they're like, okay, let me fix this puppy, and they fix it. Not in one go, not in two go, but as long as it takes. At this point in time, this puppy is horrifyingly dangerous. Why? First, it has 8 engine. Does that matter? Yes, because they built it with proper understanding that if you can't go stealth on radars, you can fry the radar. So this puppy has like special variants. People who are more familiar with this, they can type. It can roast most radar installation, like flat out. It will fry it out. And again, that's why their engine keeps getting upgraded. So the third upgrade is happening right now. I'm not sure how much power output it has, but let that be very clear. Unless you have a system that is specifically built to handle something this loud screaming, yeah, you will think, oh, I can see it, I'm gonna boom it. It's like, nah, you think it's here, it will be there. Like, you have to be like very top grade system to handle this. Like, this is a screaming puppy, and it is loud. Unless a politician is flying it, you're dead. So politician will be like, oh, we're gonna serve 5 bombers and 2 jammers. It's like, nah, 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 nah. That bad things will happen. Vietnam will happen, and they're like, okay, they'll bitch slap the politician. It's like, okay, have the army colonel or whatever have the post they have to do it properly. And again, that's the whole point of America's power. It's like, it's never that, oh, we built Patriot. Patriot is awesome. No, no, no. We built it. It was shit. Then we polished it. Now it's good. How do we know? Well, Russia and Ukraine both have systems. Somehow, Russia, which is supposed to be the second most powerful system, and Ukraine, that is ranked 22, has a few Patriot system, and still Russia does not have air superiority over Ukraine. That's the first thing you do. That's the first thing you do. And how do we know American planes can actually penetrate it? Yeah, same thing happened right a few days ago when we were talking about Iraq. Oh, sorry, Iran and Iraq also is the same story. Iran and basically Israel. Same thing. One had American system, faulty one that keeps crashing. One had Russian system, which is super awesome. We know the result. So same, let that be fair. Like, this is the whole point of SpaceX. This was Mark 1. Like, people will have hard time understanding, wait a minute, why the heck the engines were in a grid? That's how they used to have it. That octa grid that you see nowadays, I think they started to do it with Block 3. So this is how it used to look in the early days. So let that be very clear. Making a thing polished is not the game. Game is make it. Just the make it and keep polishing it. So fundamentally, I am happy that India has enough wisdom and good friends that keep slapping us at very important times. But we have to really expand that. Like, we have to grow some balls to take care of this. So this was my presentation on basically what the hell is going on with NavIC and what the hell happened. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra movement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.